are on in your book? Somebody refresh my memory. 127. This is news. This sheet. You guys have not seen the key to this sheet, have you? No, I should post that. I will today. Then you can check it. Then you can check with me on Wednesday for any ones you did wrong. Nicole. Then you reduce them just like a fraction. So, for example, if you had 14 over 12, x cubed, y squared, x, y to the fourth, 14 over 12 becomes 7/6. x3 over x becomes x squared. 2 minus 4 is -2, so the y goes down there, becomes +2. Okay? And I will do a key for that. I'll put only the circled ones up today. Okay? All right. You can check it. Tomorrow you write your test. Wednesday we're back at it. Depending on how today goes. I might put that key up in this class. You can check it today. I don't know. We'll just see how today goes. Fractional exponents cause some grief, even though they shouldn't. All right. Some of you already know what I'm about to do. That's fine. It's okay. Some of you don't. Everybody get out your calculator, please. What about the what, huh? We'll do them. They are to be given, not requested. Everybody with your calculator, do that. How do you do that? Same way you would do every exponent on your calculator. 9, exponent button, bracket 1 divided by 2. Or you could also put 0.5 in there. Doesn't matter. Tell me what your answer is. 3. Yeah? Excellent. Now, do the same thing with 27. 27, exponent, bracket 1 divided by 3. And this time you actually have to do 1 divided by 3. You can't use 0.3. It's 3. Now do it here. 625, exponent button. You could cheat and put 0.25 or 1 divided by 4. What do you get? 5. Everybody cool with that?
I don't think I'm doing it right. For the second one? I'm on the second one. I got 9.
27.
Yeah, I got 9.
X to the y. Bracket.
I got y to the x.
Great. Y to the x.
9.
No. 27.
27.
Y to the x. Bracket.
Wait. 9. Y to the x.
Why are you pushing 9?
Oh, why am I pushing 9?
27.
Yeah.
Y to the x. Bracket. 1 divided by 3. Bracket. Equals.
3.
That's what I want it to equal.
Okay.
All right.
Wait. Alright, 6, 2, 5. Wait, I think I got this now.
It's fine. It's fine.
I got 5.
Sweet. Okay. Now, let's do some logic, shall we? 9 1/2 as an exponent. 3 is the yes.
Okay, ask your question, please.
What, if any, connection can you guys divine from an exponent that has a 2 in it, a 3, and a 9? Tavleen?
Okay, pretty sure it's the square root thing, so it'd be 9, and because it's 1 over 2, that 2 is the little thing that you put.
Right. No. Don't just stop talking now, because you're getting into that thing that earlier math teachers do where they just tell you what it is and not why it works. So, with your calculator, you all knew that 9 to the 1/2 equals 3. What other relationship in this unit of radicals and exponents is there between 3 and 9? The square root of 9 is 3, yes? According to good solid logic, if this equals 3 and this equals 3, then what do we know about this? What goes in that blank? Equals. Right? Now, according to our radicals unit, this has been written not completely because math guys are lazy. What should this really look like? What should live right there? No. 2. And what is everything's exponent officially? 1. Now, please notice. Now, Tavleen, go. Say what you were going to say that I told you to stop.
Oh, okay, so like that little thingy on the one on top.
2, 2, 1, 1. If it happens once in math, how often does it happen? All the time, because math is a pattern at your guys' level. So what does this tell us? I will always like to write my exponents out with letters because it shows that it works with everything. For every law, we've done that. This law is this. X to the a over b is the b root of x to the a power. Okay? Doesn't matter what the numbers are. So let's look at this very first one, which for most of you is already going to make you go, because it's a decimal. I am going to say something that is going to bother all of you. Stop using decimals for just about everything in math class. Go back to fractions. Fractions. Trust me. Okay? What is this as a fraction? 4 over 100. Which means that I have 4 over 100 to the 3 over 2, yes? The denominator becomes the index. Square root of 4 over 100 cubed. What is the square root of 4? 2. What is the square root of 100?
10.
Cube that. What is 2 cubed? 8. What is 10 cubed? 1,000. 8 1,000th you can convert nicely in your head to 0.008. Okay? Now, the question becomes, do you really understand that? Why? At what point between our logic, which you were the one that figured out, by the way. You were the one that told me to put the equals there. Yeah, you. So what disconnection?
I think I get it. I'm just like half asleep, so like
Okay.
I'll go back and watch this and then like really get it.
Okay. So over here, what happens with the denominator? It becomes the index. What happens to the base? It becomes the radicand. And what happens to the numerator? It becomes the power. Now we do exactly what we always have done, and we simplify this. what is the cube root of 27? 3, because that is 3 times 3 times 3. There's my set of 3. Out it comes 3 to the 4th power. What is 3 to the 4th power? 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Done. Everybody cool? Now please listen to me. What have I said about all the exponent laws? They all apply all the time. So when I look at C, I notice that I have an exponent law situation. I can do 2 different things here. What is one thing I could do? Think of the exponent laws. What is one thing I can do with this construction here? Tavleen. You can multiply the 2 in there, can't you? What is 2 times 1/3? 2/3. So this is 8 to the 2/3, isn't it? What is another thing you could do with the exponent law you just learned? I guess, because no one else is saying anything.
Okay, so like you can basically write it out like you would and then do it on brackets too.
You
Okay, so we like write it out like okay, hold up. Like the 3.
right, so you're saying simplify inside the brackets.
Yeah.
Cube root of 8, no need for a 1,
Yeah.
squared, right? Okay. If we follow this way, now my next step is cube root of 8 squared, isn't it? What is the cube root of 8? 2 squared, which is 4. And here I have it anyway, in 1 step less. Does it matter which way I do this? No. Everybody cool? Does it matter what it looks like? No. Never. All the rules apply. So, D, what do I got? Now, if you're getting good at this, you might be able to leave this as a decimal. But it requires you to understand the nature of decimals. And many of you are bad at that because you didn't have to do a million multiplications of decimals without a calculator when you were kids. Two ways to do it. One, I can do what I just showed you. Square root of the decimal, 49 to the 1st power. What is the square root of 0.49?
0.7.
0.7. Why? Because 7 times 7 is 49, and I need 2 decimal places, don't I? So it must be 0.7, yes? So this is 0.7. The other way you could have done it is this. Square root of 49 over 100, correct? Square root of 49 is 7. Square root of 100 is 10. 7/10 is 0.7. Everybody cool? Now, you guys make a lot of mistakes with this, right? For example, if you try to do this in your head, for example, don't write this down. If I asked you the square root of 0.144, what's the answer? No. Because 0.12 times 0.12 would mean I would need 4 decimal places, wouldn't it? How many decimal places do I have? 3. That's irrational. 0.0144. Now, does that have a square root? What is it? Don't go to your calculators. 0.12. because 0.12 times 0.12 would be 144 with 4 decimal places. 1, 2, 3, 4. Cool? Everybody understands? If you had gone to grade 6 in 1986 like me, you would know that automatically. You wouldn't even, it wouldn't even begin to fool you. But you guys were in grade 6 in 2006, which is a different situation. No, I know you weren't, Max, but I wanted the 6s to carry on. I was doing a bit. You know, there's no such thing as time travel either, but you still watch the movies. You can't disapparate, but Harry Potter's still fun. What's weird about E? It's a decimal exponent. Have we done a law with decimal exponents? No, but we've done a law with what? Fraction exponents. And what are decimals? Fractions. That is 1.5. What is that as a fraction? 3/2. So this becomes 16 to the 3/2. Right? So what is that in real speak? Because this makes no sense, does it? How do I multiply 16 by itself 1.5 times? You can't do it, can you? So we got to fix it up. What is it? Square root of 16 to what power? 3, which is what? 4 cubed, which is what? 64. Gouda? Great. What about this one? What's that really? 81 to the 3/4, 4th root of 81 cubed. You already know the 4th root of 81 from this page. What is it? 3. 3 cubed is what? 27. Good? Good? Good. Now, I want you to look at A and B here. Why did I give you that piece of instruction? Why must you use your calculator? Because these are irrational, aren't they? They have to be. There's no simplifying. We know that this is the 5th root of 8 squared, yes? What is the 5th root of 8? There isn't one, is there? So when it doesn't work, you are bound to your calculator. Understand? But you can write it out this way. This is exponential form. This is radical form. They are equally acceptable unless I specifically ask for one or the other. Does everybody understand what I mean? Right? I don't care which way you write an answer out unless I specifically ask for one of those ways. So what's this guy going to be? Well, it would be the 7th root of 0.6 to the 15th. Ugh. Radical form. Now, how do we do it with our calculator? Same way we do everything with our calculator. Base, exponent button, bracket, numerator divided by denominator, close brackets, equals. And you'll get a crazy, yucky decimal for both of them. If I get out my calculator, 8, base, 8, exponent button, bracket, 2 divided by 5, bracket, equals 2.29. 739671, blah, 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 blah. Yeah? Yeah. What about this one? 0.6, exponent button, bracket, 15 divided by 7, close brackets, equals blah, 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 blah. Everybody good? Yeah, yeah? Okay. You now have all the things that can be done to an exponent available to you. Let's do something with them. By closing this because it's not working, opening it again because that will miraculously make it work poorly. And come back to here. Now, all of this, we are at... I am not going to waste my time with this question because all it is calculator work. Okay? You guys can try that, and I'll put the right answers up. But we're just going to leave it alone because it's just a calculator work. I want to come down to this because this is ugly. What's the next page? After that work, after that.
It's page 131.
Page 131?
Yeah.
Yep. Okay, so listen up. Oh, wait, you guys have the blue book. Okay. Because you have a test tomorrow, I am going to stop there. And I want you guys... No, I'm the worst kind of liar. We're going to do the next couple of pages notes, then I'm going to stop. Yeah. So go to page 131, please, for you guys, which should open with Simplify without a calculator. Yeah? All right. Now, the first four here look frightening. Why? Because they don't look like our notes. But the exponent stuff that we have just done is called an exponent law. Yes? Which means what? No matter what it looks like, it has to listen to the law. Yes? So what do we notice about that and that? They're the same, which means they're the same base, right? Which means, what do I do with the exponents? Add them. So that is 0.3 to what power? 2. Now, would I leave it that way? Yes or no? The instructions say simplify. Would I leave it that way? No, because there's no letters, right? I evaluate that. What is the answer? Without a calculator. 0.09. Why is it 0.09? Because I need 2 decimal places. Because it's 0.3 times 0.3, which equals 9, but I need 2 decimal places. 1, 2. What goes in the empty spot? Same thing that's been going in the empty spot since the year 500. A 0. There were no zeros before 500. Thankfully, Indian and Arabic mathematicians invented them for us. Thank goodness. Holy Toledo, 2 looks deadly until you stop for 1 second and notice what? The bases are the same. So the laws all apply, don't they? What law happens here? Pardon? So what is my exponent here going to be? Negative 8. What is my exponent here going to be? 6. Since they're still the same base, what do I do here? Add them to get what? So now I have negative 3 halves to the negative 2, correct? What does a negative exponent do to its base? If you've been paying attention, you know that it just flips, don't you? But if you haven't been paying attention, you may have to go back to the laws. That negative exponent must go to everything in here, yes? Which means I would get a negative 3 to the negative 2 and a 2 to the negative 2, yes? Which would get me 2 squared over 3 squared, because they got to flip, right? Yeah?
Would they still flip even if it's a negative? Because it's negative 3 over 3.
Yes, I'm getting back to that negative in a moment. What's the problem there? That's going to be 4/9. Max has just asked, but what about this guy right here? What happens? What do you notice about that negative in the very original question? Is it part of the base? Yes or no? Yes. So is it part of the exponents? It's very difficult, this one. Is 4/9 my final answer? Positive 4/9. Yes or no? Make a case for it. Yes, Tavleen?
Yes, but I think it's negative 49 because
You think it's negative 4/9? Okay, why? Okay. So Tavleen is saying we flip them. They flip 2 squared, 3 squared. But according to Tavleen, this negative stays all the way through. Who agrees? Okay. So now think about what you know about exponents. What is negative 2 squared? Negative 4. What is negative 2 squared? Positive 4. Why? Because the negative squares, right? So in this question, I had negative 3 halves to the negative 2, yes? Negative 2 isn't allowed. It's going to be turn into positive 2, isn't it? So whatever is in here, no matter what, is getting squared, isn't it?
Yeah, okay.
When I square a negative, no matter what do I get? A positive. Does everybody see?
Yeah.
Not difficult, but complex. Everybody understand?
I have a question.
Max.
If the minus was outside of the base.
What if this was negative? What if this looked like this? Now what's the answer? So these are positive in here. What's the answer now? Negative 4/9. Cool? Again, I remind you, it's not complex, or it's not difficult, but it requires a lot of attention, right? You have to be careful, and it helps to show as much work as you can. Don't trust your mental math yet. All right? All right, look at 3. Anything weird about it? It's only weird when you look at it, right? Because it looks bad. But what is it really? Same base. So it's just basic laws, yeah? So it's 1.4 to the what? 7 over 1.4 to the negative 2, yes? What do you do there? 1.4. What is 7 minus 2? 9. Simplify without a calculator. Can you guys do that without a calculator? I can't. So if it's something like that, that's how you're going to leave it. Because 1.4 to the 9th is a big number. Let's find out what it is, just for fun. No, it's only 20. Cool? Okay, look at 4. What's weird? It's all the same base, so that's not weird. But what is weird? Fractions. Rules don't change. What are you going to do on the bottom of that? Add them. Okay, what's 1/3 and 5/3? 6/3. What's 6/3? 2. So I got 7 to the 2/3 over 7 to the 6/3. Now, some of you are right away going to say 2 there. Why is that not necessarily a good idea? Because I got to do this subtraction, don't I? And 2/3 minus 6/3 is pretty easy. What is it? 7 to the negative 4/3, correct? Now, what can I do with that? What does a negative exponent do? Flips it over, right? So what is this really now? 1 over 7, all to what power? All to the 4/3. Am I happy with that? It's exponential form. Are we okay with it? Sure we are. Can I write it another way? Where would that exponent go in here?
4.
Just to the 4?
Yeah, cube root.
Pardon me?
Would you keep the exponent as 4 and then cube root what's inside the bracket?
You could do that. Yes. So Max is saying, can I do this? Is that okay? Okay. And this is the cube root of 1 over the cube root of 7 to the 4th, isn't it? What is the cube root of 1? 1. What is 1 to the 4th? 1. So this is 1 over the cubed root of 7, 7 to the 4th. Is everybody still cool there? Still? Everyone good? I'm going to do one more thing here that's creepy. Seven to the 4th. Cube root. That seems strange, doesn't it? If I have 4 of them, but I only need a set of 3, can't I do more stuff there? Because this is really the cubed root of 7 how many times? 4 times, isn't it? Everyone agrees? Okay. Well, what's the cube root of 7 times the cube root of 7 times the cube root of 7? 7. So isn't this 1 over 7 cube root, what did I leave under there? 7. Now this is crazy. I'll never ask you anything that hard in grade 10. But please understand how it all links back together, yes? It all makes sense if you know what is going on. If you only memorize 8 laws, this is kind of confusing, isn't it? Tavleen. Cool in the gang? And let's finish off with these 4 easy ones. I lie, 6 easy ones. And then I'm going to shut up and let you prepare for your test tomorrow or do the work that will be what you would be expected to do by Wednesday. Okay? So, first one's easy. What is it? X to the 5, y to the minus 2. Is that allowed? So what is it?
X to the 5 over y squared.
Nice. This one. Do you guys not have the a there?
No, we do.
You do. Okay, good. So, what do I do there? With the exponents, but what should I do with 10 and 5? Divide. 2. A what? B.
Just B.
B5. Thank you, Nicole. Y, Nicole. 3 minus 2. You don't get to forget grade 6 math to do grade 10 math. Subtracting a negative is the same as adding. Okay. What about 7? Does this worry me right now? You don't like negative exponents, do you? But Mr. Myers says, don't worry about it because sometimes they come out in the wash, right? So, Karina, what do I do there? So what is it? Positive 15. It came out in the wash, just like we said. Now what do I do with 15 and 5? 1.5 to the 10th. Could we take that further? Because that's technically 3 halves to the 10th, isn't it? Which is technically 3 to the 10th over 2 to the 10th, which is a stupid big number divided by another stupid big number, but you're going to end up with something like 20. So we're not going to go any further than that. Does everybody understand? Just for fun. I lie. You're going to end up with 58. But it's still, if you did this, you would get 59,049 over 1,024. But who cares? This one messes people up. Again, should I be concerned about that fractional exponent yet? Yes or no? No. Why? What happened to the concerning exponent here? Did it disappear? So what do you think is going to happen here? Or what do you think might happen here? it might disappear. Where does that 1/3 have to go? It's got to go to everything. Why, Asa? It has to go to 8 because it's in the brackets. So that is 8 to the 1/3, which we already know is the same as the cube root of 8, which we know is... Say it louder, say it proud.
2.
2. What does it do here? What did it do here? So what does it do here? What's 3 times 1/3? 1. Not trying to fool you. I got 1/3 of the pizza. Max got 1/3 of the pizza. Lauren's got 1/3 of the pizza. 3 times 1/3 is 1 whole pizza. What's 6 times 1/3? 2. There we go. Okay. Do you see why I'm doing this to you guys? You guys stress needlessly, right? You look at that and you're like, oh my God, fractions. And you shrivel up like a tulip when the sun goes away. I did that on purpose. I have 4 tulips that grow wild in my front little garden box that I do not tend to, and yet I have lived there for 8 years, and 5 tulips continue to grow there. I have never planted them. I have never weeded it. I have done nothing. Yet tulips grow, 5 of them, in front of my house. I am thinking of starting Lewis and Hamilton Tulip Festival, but I'm worried about the traffic. There's 2 reds, a yellow. What's there? 1 red, yellow. I don't know what the other one is. There's 5 tulips, though.
White?
There might be a white one. Yeah, there's 10 lips. Because 5 times tulips?
No, it's surprising how many people make like dumb jokes like that. Like some Asian guy, like, hey, his daughter was like, Dad, let's go look at the 2 lips, and he's like, are you sure you don't want to look at the 3 lips? Like.
Look at 9. Does it look frightening? It looks frightening, but is it? No, because it's 4 over 2, a to the negative 2 over a to the 2, and b to the 2/3 over b to the 1/3. What do you do there? Divide. What's 4 divided by 2? 2. What do you do there? Subtract. What's negative 2 minus 2? Negative 4. A to the negative 4. Why is Mr. Myers leaving that as a negative 4? Because I'm not done yet, and I still don't 100% know what's going to happen. What do I do here? Okay. 2/3 take away 1/3.
1/3.
Yeah! Pre-IB math, baby. Good job, guys. B to the 1/3. Now do I have to fix it up? Okay, there's 2 ways this can be written. I want you to write them both ways. It's very, very tricky. One is exponential, one is radical form. He listens for the flippy of pages. Everybody should have been able to do that one pretty much right away, yes? Okay. What is it as radical form? 2 cube root b over a to the 4th. Because that is that, yes? Cool? All right. Now look at 10. Yuck. Barfy, hey? Split it up. Do something. Now, you have a couple of choices here, don't you? What is choice 1? Simplify where, Nicole? You could simplify inside the brackets. All of this, can't you? And then deal with this. Or could you bring this in? Right? It doesn't matter. You do what you're comfortable with. I am going to simplify inside the brackets to get 4a to the negative 4. Now this is where it gets tricky. B to the negative 1/2 in a denominator. Where can I move it? Up. Why? Because it's negative and it's already in the denominator. To the positive 1/2. And all of that is to what power?
1/2.
1/2. What is the power of 1/2 really? No. X to the 1/2 is really what? Square root of x, isn't it? So 4 to the 1/2 is really what? Square root of 4, which is 2, right? What does this do over the bracket? What do all exponents do over brackets? Multiply. What's negative 4 times 1/2? Negative 2. A to the negative 2. B, what's 1/2 times 1/2?
1.
So close.
Oh, 1.
1/4. Am I okay yet? What about that is not okay?
It would be 2b 1/4 over a2 squared.
Is that okay? As exponential form. Can I write it any other way? 2 4th root
6.
of b
Oh, it's a
over a squared. Everybody good? All right. Listen to me closely, because this is going to be a little strange. What time is it? I am going to risk trusting you with 11 and 12 and 13 and 14. You're all going to screw up 12. Challenge accepted. No, I'm totally confident in you. That's why I did that. Because when I say that, you all go, Dick, and you do it right. All right.
I'm gonna start with that.
You go, guy. You do page 132, 133 in class today. And then there were 3 pages in there of work. There was page 129, which is entitled page 227. There is page 134, which is entitled 233, and 241. Okay? When do I expect all that done by? Wednesday. On Wednesday, we are going to work in class on an exponent assignment. Wednesday. Because tomorrow is Radicals Quest Day. Okay? Okay. Now, please notice, even though we did a half unit on radicals, they have come back in exponents. So when I give you your review assignment on exponents, there is going to be some radical stuff in it because you need to know radicals to be able to do exponents. Yes? And when I give you your exponents quest, there will be some radical stuff on it. Just like when we did radicals, it helped to know a bit about exponents, right? Because when we were pulling out squares and cubes and things, right? Everybody good? No, you never have to do all the questions, right? Your amount of practice is the amount of practice you need to do to get the grade you wish to have. If you find yourself not getting the grades you wish to have, then the only thing that can be done is more practice. If you find yourself getting the grades you wish to have, then you are practicing exactly enough. Okay? The only stuff I demand that you do all of is stuff you hand in to me for marks. And handing in something for marks that has the answers attached to it is not much sense. Because if you don't know what it is, you're just going to write the answer. I'm not sure what you mean. For example, on in your book, page 137 says radical review, and you will notice there are no answers attached to that. So do you think I am going to be marking page 137, 138, 139 for marks? Yes. It's at the end of the assignment. You've had tons of practice that you can choose to do. And by that time, by 1:37 on Wednesday, I expect you to be able to do that without having something to check. Okay? I will never take anything for marks that you haven't had the opportunity to practice on. If you choose not to practice on it, that is not my problem. Understand? Somebody just put a hand up over there. What?
I'm gonna be away tomorrow.
If only there was some sort of technology.
No, I know. I'm just letting you know. So
Yes, that is fine. If only there was some time built into the school week where you can come and redo things that you miss. Right? Next Thursday would be X block. Everybody go!
Actually, next week is Clock
Is it? Yeah. Oh, right, because Thursday is technically no school. Right, yeah.
Your birthday's
I know my birthday is no school.
Did you hear how well we did?
I did hear on the news there. It was
It
spectacular.
was spectacular. Clearly, we could not have beaten anybody from Vancouver Island.
Yeah.
And we did it with, 6 girls.
Yeah. You would like some what?
Cake.
Those are 2 bite brownies, so I can't help you.
I wasn't asking you. I was just stating.
Oh, okay.
That's it.
Now remember, you are not in school on Thursday, so that makes your birthday planning for me slightly more difficult.
Guys, surprise party on Wednesday.
I'm not here.
Was anyone really gonna do it though?
Mr. Myers, what do you like to eat?
What do you mean? What do I mean?
Like, is there anything like on your birthday that you don't want to eat? Like sauce?
Do you remember that there was an ad for TELUS? Something weird is happening here. I appear to be recording and watching a recording.